Hello and what is up, YouTube APES class? So that's just a little preview to the video that you may have already seen or that you should look for, which is my mug collection tour. This is one, it is a Rhode Island mug, so I can't wait to show that to you in that video, or maybe you've already seen it. So I just want to take some time here and go through the next PowerPoint slides that you will be taking notes on today. So without further ado, let's bring this on up and show you guys exactly what we are talking about today. So we're going to be moving through slides 40 through 37. We've already done the acid deposition. So we're going to be moving through slides 40 right here through 47. So it's a quick one today, but I also have a FRQ for you to work on today and a little bit of reading to do. So quick on the slides, but there's a little bit more work to do afterwards. So without further ado, let's get this rolling. That way you can get a jump start on that work. So we've talked about we've talked about outdoor air pollution. We've talked about major air pollutants. Let's talk about how we want to get rid of this pollution. We've talked about how pollution is trapped. So how do we get rid of it? Well, there's a couple of main things here. We can dilute it. Okay, dilution is the solution. Winds often blow the pollutants away. This is why living in a valley is bad, right? That photochemical smog gets trapped there. Winds blow them, the winds move the pollution away to different areas and dilute them as they move them. So rain or snow, pollutants act as a condensation nuclei and they are washed out of the air. So when it rains, when it snows, it brings that pollution out of the air, then down to the ground. So it's no longer air pollution. It kind of just like drowns it all out. How do we get rid of air pollution? We follow the Clean Air Act of 1970, which I'm going to link up a little informational section later on in this video right at the very end. And then we have air pollution control systems like catalytic converters, platinum oxides. They control your NOx, your COs, and your VOCs. All right, moving on. So now if we're talking industry removal of pollutants, we're talking about electrostatic precipitators. I don't know about you, but electrostatic precipitators, man, that is just a satisfying word to say. Electrostatic precipitators. What do you think? So in electrostatic precipitators, it is a way to clean or remove pollutants from gases before they are released into the atmosphere. So particulates are ionized. They are collected by a charged plate. The particles are then collected and disposed of, and the cleaner gas is then exhausted into the air. So what happens is they essentially charge the particles, charge the pollution. It's then given a negative charge as it moves through these positive plates, then pull that pollution out, pull those charged negative particle pollution out, and they're collected and then disposed of. So that is how we kind of try and do our best to clean the pollution from the air. So electrostatic precipitators, it's kind of in the name, electrostatic, right? We're charging these pollution particles. This again is an electrostatic precipitator. You can see it is almost like a filter. These charged plates, I don't know if you guys have ever seen like a clear air filter or an air ionizer. It has these grates, right? These metal grates, you can take them off, you can clean them. They are charged, and as the air moves through that, it's attracting all of these other charged particles. Opposites attract, right? And it pulls those particles out of the air, and it gives you the cleaner air as it travels through, which is exhausted. Same idea. We can then remove those plates, wash them off, get rid of the pollution, and your air is oh so clean. Now, again, this is just a step-by-step of what's going on. Dirty air comes in, particles are negatively charged, they're removed by the positive plates. The positive plates can then be taken out and cleaned, and the cleaner air moves on through. Now, not only do we have electrostatic precipitators, but we also have these things called scrubbers. Cheers to scrubbers. It's a red velvet coffee, not bad. I do enjoy like hazelnut, French vanilla, red velvet, cinnamon bun. That is an excellent coffee. Then I'm all about the normal blends, right? Like your dark roast, your espresso roast. You know, those are always good too. Yep. So yeah, yeah, definitely enjoy the coffee. Love the coffee. Drink it black. To me, that's the only way to drink it. Very tasty. Moving on to scrubbers. So what happens here? I like to think of this as a car wash for your air. So what happens is the air, as shown in the left diagram, the air comes in and it moves through these sprayers, these scrubbers, and essentially the water is sprayed out. It collects onto the fine particulate matter, and that precipitates it out down to the bottom where it can be collected, recovered, and collected, and then disposed of. It's essentially a car wash for your pollution. Again, here's a diagram of a scrubber. The air moves in the scrubber, combustion exhaust removes shower mist. The mist collects the particles. Dirty water moves the sludge to the removal system. Sludge is separated. We remove it. The water moves back to reuse in the scrubber. It's very important. You don't want to waste that water. And the cleaner air exits the stack. It is a car wash for your polluted air. I don't know about you, but I'm more of an electrostatic precipitator type of person. To me, that just does a better job. It's clean. To me, it's cleaner. It's neater. Much more streamlined. This, to me, I don't know. I mean, like I said, more of an electrostatic precipitator. What about you? What's your favorite way to remove pollution from air? Moving on, let's take a look at these airbags. What we have here is a bag house filter. This is very familiar with, I don't know if you're familiar with like wood shops, but a lot of times what they will do is they will collect these filter bags up to a bunch of the different woodworking machines. They then collect the dust that comes out. This is very good for particulate matter. The bag inflates because of the airflow. It collects all of your particulate matter, and then like any other filter, the air is released throughout. Again, this is for solid particulate matter, not necessarily for your gases, your NOx, your SOx, stuff like that. This is more for your SPM, your solid particulate matter. Moving on, we are almost there, guys. I told you this was a quick one. This will be a blink and it's over. Innovative pollution control. We're looking at local and controversial measures. Reduce the amount of gasoline spillage. Restrict lighter fluid use. Reduction of wood-burning stoves. I don't know about you, but I got a wood-burning stove right now. But there's prevention in that wood-burning stove. You have what's called a catalytic converter. If you engage that, it burns the fuel more completely, and then you have less exhaust going up your stack. Maybe tolls for burning during different types of day. Tolls restricting car driving. Anything to try and keep down on air pollution. They are radical ideas, but they are ideas. Clean Air Act allowances allows buying and selling. Okay, these carbon credits, right? You've heard of those. So I'm going to burn more, so I'm going to purchase credits from someone who burns less, right? It's still the same amount of pollution going up into the atmosphere. It's just more is coming from me and less from you. Think that's a good idea? I don't know. Shouldn't we all trying to cut back? A question to ponder. And the number of total allowances has greatly been reduced. In 1982, we had 23.5 million metric tons. In 2008, we decreased to 10.3 metric tons. So we cut that in half. It's a wonderful thing. And how do we do that? Well, here's our Clean Act. I would encourage you, I can't link this up because it's not another YouTube video, so I would encourage you to take a look at this website and just read through it. So everybody have a great day. I will see you in the next video. Make sure you're doing the reading, make sure you're answering the FRQs. And this is Mr. F saying, hold on, let me think about a witty rhyme. Air pollution, pollute the air. Why don't we all just care and not pollute the air? Yeah, not my best one, but hey, I'm trying. Take care, everybody. Bye-bye.